Right, here's a combining uncertainties question. We get the equation and the graph here. Oops, too thick. So that's the graph and this is the equation. So now the first thing I'm going to do is get an expression for the gradient just down here. So a squared v squared equals 4bwt. Move the a squared onto the other side. So I get 4bw over a squared times t. Now this thing here equals the gradient. So rearranging for b, I'm just going to go up to the top. B equals the gradient times a squared divided by 4w. Now we need to get the individual uncertainties. Let's start with the gradient. So I've got the maximum minimum here. The average of those two is 27.2. And I take half of the range, half of 3.8, which is 1.9. And as a percentage, that's plus or minus 7%. For A, since it's a measured value, it's already given. So we can get the percentage from that, 3.3 divided by 46.5, which is also 7%. For W, it's a physical constant, so we use the last significant digit, which is 0.1, as the uncertainty. That works out to 5.3%. And so I can calculate B now from all of those. The first thing I'll do is I'll just put the numbers into the equation, and that gives me 7,739. Next thing I'll do is I'll combine the uncertainties, which is what this whole question is about. Since they're all multiplying or dividing, I simply add the percentages, but I must be careful for the squared up here. So this is adding once, this is adding twice, and this is adding once. So I do 7 plus 2 times 7 plus 5.3, and that gives me 26.3%. And then I can do 26.3% of my 7,739, and that gives me an absolute uncertainty of 2,035.